Okay, that's good. So let's write. It said in an example, when a nitrogen 14 7 is bombarded with an alpha particle of a certain kinetic energy, it transforms in oxygen 17 8 and a proton. Now they've given you some data, which is nitrogen 14 7 has a mass of 2.32530 times 10 raised to power minus 27 kilograms. Oxygen 17 8 is given as 2.82282 times 10 raised to power minus 26 kilograms. Then they have given you the mass of alpha particle, which is 4.00260 U. They have given you the mass of proton as 1.007276 U. They've given you mass of neutron as 1.008665 U. And they've also given you mass of electron as 0.00055 U, like that. Now, what they say is, in the first part of the question is that write an equation to represent this nuclear reaction. Then in the next part, they say, what is the minimum energy needed to make this reaction possible? Okay. These are the main things that you guys need to do. So first of all, having to, now you don't need to do anything, you just need to remember that you have to read it out, that when nitrogen is bombarded with alpha particle, which means you have to add nitrogen 7 plus an alpha particle, which is 4 2, we should remember that. Then it transforms into oxygen 17 8 plus it gives off a proton. It is written in the question, you can just write it down. The two things is that you need to remember the mass of alpha particle and proton and the charge of alpha particle and proton. Once you're done with this, then we need to understand that in any
Sir,
reactor, yes,
this mass of a neutron, it is 1.008665 or 8005.
8665.
Alright, thank you.
Okay. Then it says, what is the minimum energy needed to make this reaction possible? First of all, we need to understand that mass energy must be equal, since in nuclear reactions, mass energy is conserved. Okay. Now, the left hand side should be equivalent to the right hand side. We should understand that. So now I'm gonna basically find that out. I don't know what they do with this, but they really mess up things. Okay, anyway. So first of all, total mass on right hand side is equal to oxygen 17 8 plus a proton. So we're gonna add the masses. If you add both the masses, like 2.82282 times 10 raised to minus 26, and then basically you have to convert this into U. So I'm gonna divide it by 1.66 times 10 raised to minus 27. I should get around 18.0066983 U. So this is the oxygen's mass plus, sorry, wait. That's not correct. That's not correct. Wait. Instead of converting this directly, what we can do is we can use this mass 2.82282 times 10 raised to minus 26 and add the proton's mass, which is 1.007276, and then multiply it with 1.66 times 10 raised to minus 27 kg. I think this should come out to be somewhat around. Can you guys please try this? What is the answer for this one? Maybe it's wrong in my notes. The other class may have miscalculated it. I think it should be something different. Give me like more significant, please. Oh. Wait.
I'm getting 2.99027.816 times 10 raised to power minus 26 kilogram.
2.99, then
0.027.816 times 10
times
to the power minus 26.
26 kilograms. Okay. Then what you do is you guys need to find the total mass on left hand side now. So that would be basically the mass of nitrogen plus the alpha particle. So I think you just need to do 2.32530 times 10 raised to minus 26 plus alpha particle's mass was given in U 4.00260 times 10 raised to power, times 1.66 times 10 raised to power minus 27. And you should expect some answer like this 2.98995. You guys can check as well.
2.9897316.
2.98973. Okay, 162. Okay. And then you can basically subtract this to find the change in mass then. That I think what previous class calculated was this one. In U, I don't know.
That's going to be, in terms of kilograms, 2.96216 times 10 raised to power minus 30.
You subtracted it?
Yes.
2.96.
Times 10, 2.96216
216 into 10 raised to power negative 30.
kilogram.
Yeah, and then you have to divide this by, if you divide this by 1.66 times 10 raised to minus 27 kilograms, you get the answer in U. What is that?
To 5 decimal places, 0.00178.
Like that? Okay. 178 U. Then what you do is, it's very simple. If they've given you 1 U is equivalent to 934 MeV, then what will be the equivalent energy in MeV then? Just need to multiply this value. Just need to multiply 934 with this value.
That gives me 1.666 MeV.
1.67 MeV, right? So this would be basically the minimum kinetic energy required by alpha particle for this reaction to happen. Is it clear, everyone? Because after formation, if you see after formation, the right hand side has a greater mass than the left hand side, which means the initial kinetic energy of alpha particle must have converted to mass. Is it clear, everyone? Zainab, Huda, Samir, Aisha, Khatija, and Shiza. What about you,
Yes.
Abubakar, Abia, Abdurrahman? Okay. So this is something I just want to tell you. So now the last part of this topic is radioactivity. We're going to go on that. So let's have a look at this. So for radioactivity, you guys need to write the definition first. It is defined as the random. So this is the attributes of it. Random and spontaneous decay of an unstable radioactive nucleus to form a more stable nucleus or nuclei. This results in giving out alpha, beta, and or they can be all present or one of these gamma radiations. So this is basically the disintegration. So you can write this down, please. While you're writing, I'll be back in like 1 minute. Okay, kids. So now let's define what is random and what is spontaneous. So these are like two attributions of, of radioactivity. Let's give them that. So, first of all, the random. Random basically means that it refers to the probability of decay of any or all nuclei at any given time. Like you cannot predict when a nuclei or all nuclei or just a nucleus is gonna, decay. So this is the reason you will see random right here. You will see random fluctuations on decay curve is represented by this. All right. So there will be like ups and downs all the time. Then you have spontaneous. Spontaneous means that the decay is unaffected by any external factors such as pressure, temperature, force, etc. Like you cannot increase, decrease the speed of decay. It will decay when it wants to. And this one is represented by the trend of the graph. All right, kids. You write it down, please, while I'll draw the graph. So the graph of decay generally looks like this. Number of particles here with respect to time. So you see a line like this. This line basically shows it's an exponential curve, and this is just the average line. The real line looks something like this. There are random fluctuations on it because of the random nature. So the actual line, the blue one, shows the random nature, and this exponential curve, basically the curve shows the trend, that's spontaneous nature, because it would just decay when it wants to. It doesn't really get affected by any factors at all.
Sir, what did you write in pink?
Represented by trend of the graph.
Okay, thank you.
Okay. All right, kids, you done? Should I go forward, please?
Yes, sir.
Draw. All right. All right, kids. So now let's have a look. So let's look at the probability of decay. First of all, this is the most important part. Probability of decay is basically the change in particles over the total number of particles, right? Which can be, for math people, it is the derivation of this over n, so you can remember that as well. All right, so this is something you guys need to remember. Then decay rate slash decay constant. All right, decay rate or decay constant is basically called lambda, and it is the probability of decay per unit time, or you can simply write it is change in probability of decay divided by dt. So for math people, you know what derivatives are. Anyway, the definition of this is that decay rate or decay constant, it is the probability of disintegration per unit time. It's a scalar quantity and it is measured in second minus 1. So this is the SI units. You can write this down, please, and then I'm going to go forward.
So basically, we find the gradient of the line and then divide by t again.
Sorry, come again?
So we basically find the gradient of the line at any given point and then divided by t again.
Yeah. No. No, no. That's not it. Gradient of line is change in n over change in time. That's not the same case. Okay. It's a constant value. Okay. You guys can do this. Then I'm going to go forward. Just wait. Now, for only math people, I'm going to do a small derivation so for their own understanding. For people who do not take math, they have biology or something like that, you don't really have to do this. It's not necessary. Neither they will ask you anything about that. So basically, now for right now, what is required for you to learn is that since lambda is equal to dn over n by dt. So you can multiply n on that side. So it will be lambda n equals to dn by dt. All right, is it clear? Basically, it is the same thing as like this. So D means change. And we're going to put a negative sign here. And why do we want a negative sign here? Because negative shows the number of particles reduce. It's basically the curve goes down. So that's why there's a negative sign. So you can write it down, please. This formula is very important for this. All right, kids, should I go forward, please?
Yes.
Okay. Now the last conclusion of this is needed, but just for the kids here. So this is not for non-math people. Okay. All right. So this is and not required as well. So first of all, you math people, we'll use the same formula. We can bring lambda here, dt on this side, and then we can take dn over minus n like that. So then you can take the integral on this side. If you take the integral, it's going to be with limits of t to 0, lambda, and then you have 1 dot dt. All right, so this is for A2 math. then minus this integral will be n from n naught, so this is the limit, and 1 upon n dn. Now, as you can see, 1 dot dt has a integration of just t. You guys agree? And this one will have from n to n naught, it will be ln because there's a function down of the same derivative. So we're going to bring n here. So that means that this will be t0 will be 0, so this will be lambda t equals to minus, then you put the limit, so one limit will be ln n minus ln n naught. All right, kids, ultimately you can bring the negative on that side. This will bring us into, because this is a the function here of log, so we can put it like this, and from here we can take exponent, and exponential of this one will give us just n over n naught. Now, for all non-math people, we need to remember the equation, which is n equals to n naught e minus lambda t, and this is the equation that is required, okay, for everybody. So those who are in math can write the stuff on the left, but the highlighted formula needs to be remembered all the time for everybody else. Okay. All right, kids, done. Any questions here? Please let me know. Now, the next thing I want to tell you is that this formula can be shared with other stuff in this. So I'm going to write three formulas here with respect to number of particles. Then we're going to write with respect to activity. And then with respect to mass. So for number of particles, you will be using n equals to n naught e minus lambda t. For activity, you will be using a equals to a naught e minus lambda t. For mass, m equals to m naught e minus lambda t. So these are the three things, three formulas that you guys should always remember. Now, what these mean? Yes?
Wait a minute, aren't all of these just like the capacitor discharge equations?
Yeah, because capacitor discharge is also exponential equation, so they are all the same with different constants. In capacitor, we have T upon RC. In this, we have lambda. Get it?
Yes.
In future, like topics, we have X-rays. You will find the similar formula for that. So number of particles at time t is this equation. N naught will be the initial number of particles, and then lambda is the decay constant that we have just done, and then t is the time elapsed. Okay, so you can basically write the same things for everybody else.
Is there any precise value for decay constant?
Every radioactive material will have a different decay constant.
All right.
Okay, for the rest of these, you can write this is M, which is mass, sorry, A, which is activity at time t. A naught is the initial activity. Then for this one, M is the mass at time t, M naught is initial mass, and rest of the things are the same. So you can copy this, please, and then we shall go forward.
Done.
All right, wait for this, please. All right, kids. So from this point onwards, we're gonna finish this chapter tomorrow, inshallah, and then I'll see you. Okay. Have a
Okay,
nice day.
sir. Allah Hafiz.
Allah Hafiz.
Yeah.